So in problem number 8, we're looking at a genetics example here. So a geneticist is studying two genes. Each gene can either be dominant or recessive. So we took a sample of individuals and categorized in this table. They looked at gene 1, whether it was dominant or recessive, and then gene 2, whether it was dominant or recessive. And so, for example, this 18 right here means that gene 1 was dominant and gene 2 was dominant. And the 34 means that gene 1 was dominant, but gene 2 was recessive, and so on. And then we did row totals and column totals here. So the 52 is the total number of individuals where gene 1 was dominant, just looking at gene 1. 38, the total where gene 1 was recessive. 40 is the total where gene 2 is dominant. 50, the total where gene 2 is recessive. So we want to know what's the probability that a randomly sampled individual has gene 1 as dominant. So the probability that gene 1 is dominant is going to be desired out of total, because it's equally likely that we'd pick any of these 90 individuals. So gene 1 is dominant in 52 individuals here. That's our desired outcomes out of 90 total. So 52 out of 90. So 0.58 repeating. So 58.89%. Probability gene 2 is dominant. So gene 2 dominant this column, 40 out of total of 90. So 4 divided by 9, 0.4 repeating. So 44.44% probability there. Probability gene 2 is dominant given gene 1 is dominant. So remember here that the given condition determines your total outcomes. So we're given that gene 1 is dominant. So that means that we are in this row, which has a total of 52. So our total outcomes is 52. And then out of those 52, how many have gene 2 dominant? So gene 2 is dominant in this column, which is 18. So 18 out of 52. .3396. And then lastly, two genes are in linkage equilibrium if gene 1 is dominant, is independent of gene 2 being dominant. So what we want to do is we've got the probability that gene 2 is dominant given gene 1 is dominant. So they'll be independent if the probability of gene 2 dominant is equal to gene 2 dominant given gene 1. So in other words, if they're equal, then this given condition doesn't change the probability, doesn't make a difference. Well, gene 2 dominant is 40 out of 90 here. And then gene 2 given gene 1 is 18 out of 52. And those are not equal. So the question is, are those equal? No, they are not equal. Okay, so they are not independent. And independent means that you're in linkage equilibrium. So are they in linkage equilibrium? No. So no linkage equilibrium. I'll abbreviate that LE. So now if these two had turned out to be the same, the 0.44 and the 0.3396, then they would be in linkage equilibrium. Now again, we could have done gene 1 and 1 given 2. It's just you want the first event to agree here. And you want to check and see if those are equal.